Alright, so today I want to go over the water pump that I'm using on my truck. As you can see in the photo here to your left, that is the pump I'm using. It is a BMW uh, pump. It's made by Pierreberg. It's called the CWA400. It's a 400 watt pump. It'll draw 36 amps, full tilt. It's PWM controllable. Um, it's amazing. I mean, it's brushless, found on BMWs to last over 150,000 miles. Very reliable, simple 1.5 inch in and out ports. Um, and it's small. It's about the size of a can of soup. Um, I'm going to leave links in the video description to the information on the pump. It's made by, or the website, it's not made by them, but the website is Tecomotive. Just go back to them. There it is, Tecomotive, right here. I'll put a link to that. But they have all this information on this pump, and it's fantastic. I mean, the operating range, how much amps it pulls, its discharge rate. This discharge rate, when converted to American, is 58 gallons per minute at 8 psi, which is a lot of flow rate. A Meizere HD flows 55 gallons per minute at 0 psi, so imagine what it's like if you throw some pressure at it. It goes down significantly. So this pump gets sometimes confused. If you look closely, you can see this back, how it's kind of like a pressed on kind of back housing here, and this connector's square. This pump gets confused with the CWA400, so don't get them confused. The 400 is much better. This is you can kind of see it a little bit so far, but I want to get a better photo. Part of it is the connector. This is a long connector instead of the square. You have like a 90-degree mount. Like these mounts are like 90 degrees offset instead of 180-degree offset. You can see it in the data sheet here. Got this, square connector or this rectangular connector. Will it work? Yeah, I mean it'll work fine, but the 400 is the way to go. The 400 will flow a lot. You can see here how these are 180 degrees opposed from each other. So when you're looking for the pump, here's your part numbers. Here's the Pierreberg part number. When you're looking for the pump used on like eBay or in a junkyard or whatever, you can use those part numbers for reference to find what you're looking for. Now, if you can't get a connector, which I wasn't able to, you can just go to Ballinger Motorsports and you can order the connector. I'll include a link to that as well in the description. It's 21 bucks plus shipping. They actually charge you pretty heavily on shipping, unfortunately. But it's a brand new connector, solders right in. Just do it, make it easy on yourself instead of trying to hunt one down in a junkyard. So very simply, I'm going to go over what all 4 wires do and make it simple because this is probably what you're going to be looking at, less so than a wiring diagram. The 2 black wires are just ground. One's signal ground, the small black wire, and one's main ground, which is where the power of the pump goes through. So you just tie those both to each other and put them right to a body ground. The small red wire, that's your PWM signal, and then the big red wire, which is pin 3, that is your main fused power to the pump. You don't have to put this on an ignition switch or relay or anything like that. Just hook it up to the battery with a 50 amp fuse in line. This pump only draws like 0.2 milliamps in standby, so with the key off and the pump not running, it barely does anything. You have to send a wake-up signal to it in order to get it to turn on, which we'll go over. It's pretty simple, but this pump needs to see PWM signal between, let's see, here we go, 50 to 1,000 hertz. It's not looking for a specific frequency in that range, it's looking for duty cycle. Duty cycle is what actually controls the pump. So these numbers here are going to look, if you actually try to use these numbers in the Holley, it'll operate the complete opposite of what you want. The numbers are inverse. So this duty cycle, it's actually in reference to the positive 12 volt slope. So 0 which would be, say, 100% duty cycle on the Holley, since we've already established that it's ground only, it'd be grounding out the pull-up resistor, which would give you a 0 duty cycle that would stop the pump, as well as if the key is off. And if the key is off and you don't have a 12-volt signal going to the PWM, the pump's off. So you can see here the controlled operation, 13 to 85 for controlled operation, then 86 to 97% max speed. I typically just do 95%, which would be 5% on the Holley. But here's the cool thing. Say you don't want to use PWM, you just have a drag car, you just want the pump to run full bore all the time, you don't want to waste an output. That's fine, you can do that. 98 to 100% emergency running, 95% speed. Still better than any of the Meizere pumps, still better than the stock pump. It'll cool you down really fast, as long as you have a good fan to pull the heat out of the radiator, because the pump's only half of what you need to do. So let's go to, see what photos do I have here. That's just a photo of the connector. Go over that. That's for thermostat operation. Here's how I have it set up in my truck. I have it just in line between the radiator and the water pump. I gutted out my water pump in order to do this. Oh yeah, I wanted to go over the pull up real quick. Pull up, yeah, you got your 5K ohm resistor. The output, you just, as long as you pin it right to the Holley, you'll be fine. Just follow that diagram. If you get lost and you don't know what to do and you're pulling your hair out, it's pretty easy. Just make sure that this resistor isn't on the other side of this loop, right? Or it won't do anything. This is how it has to be. Okay, so for the pump, I gutted out my stock water pump internally. Like, I removed the impellers off the shaft, and it's pretty much just an idler pulley now. Which, if you're trying to buy the Meizere pump that has the idler pulley, that's $900. So now we're talking about saving a lot of money with having a pump that'll outperform it. So here's a pump that I'm using for my Volvo. This isn't the one in my truck. I just cut the snout off as well. I'm gonna, a 1.5 inch freeze plug was gonna go in the front here with some sealant, and it'll be good. This hole here, you need to block off. Whether you just tap in an aluminum plug or you get a freeze plug. It's a 31. I've looked at the guys that do the thermostat deletes, because there's a proper way to do a thermostat delete on an LS, so you can maximize the performance of your pump. And they use a 31 millimeter freeze plug for that hole. I don't know if a 32 millimeters are really easy to find. I don't know if it would work, but that's just what I read was 31. Until I try it, I won't repeat it with certainty that that's what they used. So anyway, you block that off. Now the nice thing is that the flow path of water without a thermostat just goes from the discharge of the pump into the thermostat housing, through the bottom ports of the pump, through the block, up through the cylinder heads on the return path back, through the top here, discharge, boom, right back to the radiator, and goes all the way back through. You can flow a lot of water through the LS this way. And if you block off, if you don't want to use a freeze plug, you can buy this thing too. It's made by a company called Racecast. It's like $25. You can run that if you want. I've never used it. I won't say if it's good or not. I have no need to use it. I have scrap aluminum. So you can, in this way, you can, if you have a full-blown race car, you don't have to run that stupid loop that a lot of people like to run. You can just cut it off completely and put plugs in it. Or if you say have a heater core, or say you want to run a thermostat on this setup, you can run a thermostat with a caveat. You'll have to block off this front port. This will have to go out to your heater core, And on the return to the heater core, it's going to have to go to the suction side of the pump. So that means that you should weld a bung in your radiator on the cold side, on the cold side of the radiator. So that way it'll come back in, get sucked in through the pump, discharge, go through the motor, and then on the return path back, it's going to be met with the ability to go in two directions. Either it's going to go to a remote thermostat, which is on the upper hose, or it's going to go back through the discharge or back to the suction side of the pump. Now, because it's such a small line, like we're talking, 5/8 inch heater hose, similar to how the LS is run with the heater core, it's still going to have, as you increase pump speed, it's still going to be sending a lot of flow through the engine. If you want to maximize the amount of flow in the engine, you're going to want to block off both of those ports. You're not going to want to send anything to a heater core. But say, for instance, you want really good heat in the winter and you live in like the Northeast and it's cold, like I do. You can run a thermostat this way. You just need to buy the remote thermostat and put it in the upper radiator hose. I'm not running one right now. I just block off half my radiator with a cookie sheet, and that works fine. I still get 185-degree temperatures and keeps me nice and toasty, and I'm fine with that. Now we'll get on to we'll get on to building a table. So I'm going to just copy this, but we'll build this from scratch, just so it's easy for you guys. I'll just disable this. We'll make another one. We're going to call this water pump 2. Okay, so water pump 2. We're going to enable it. We don't want to ground. We want to PWM because we're going to PWM it. And we're going to go to the pin map. We're going to pin that to water pump number 2. You just pick whatever output that you pinned it to, right? So let's just say we put it on output 4. Cool. Go to configure. You don't need any sort of input switch triggers or anything like that. But what you are going to need is an activation delay. The reason why you need the activation delay is because it needs a wake-up signal to start the pump. So it's only supposed to be something like 3 milliseconds, but I mean, oh no, my water pump didn't start for 100 milliseconds when I keyed on the car, whatever. So I just put in like a 0.1 second wake up timer. And now we're going to do fixed frequency, and we're going to set this to 150 hertz. Again, anything between 50 to 1,000 hertz. Lower frequencies tend to be more stable if you're not shielding wires and you happen to be running wires over stuff like ignition sources and whatever. I just picked 150 in my case, and it worked fine. So now, for building the table, I like to have 2 ways of pulling heat out of the motor, especially if I'm not running a thermostat. I want proactive heat removal and I want reactive heat removal. So proactive heat removal you could think of being load-based. So the more fuel you use or the more load you put on an engine, the more heat you're going to put into the coolant. And then as well as the hotter the engine is, the more heat you want to remove out. So heat removal is dictated by mass flow rate of the coolant, which means you're going to need to have more pump speed. So we're going to PWM the pump more. So to do this, I'm just going to set up a table using coolant temp sensor and TPS. Oh, I'm actually going to do it the other way around. TPS and CTS. So for coolant temp, let's say, so minimum pump speed is going to be, it says 13% on that PWM info, which I'll just show to make it easier. So minimum controlled speed is going to be 13%. So in order for me to get from minimum, or in order for me to put minimum into the Holley, I really need the inverse of that. So very simply, just do 100 minus 13, just 87%. So we're going to go into the Holley. We're going to put down 87% here. And for coolant temp, we're just going to do 160 to 220. Always fill your columns just in case it doesn't interpolate well between the cells. And if you haven't built a table here before, this will always pick a cell. Okay, so if you are, say, at 120 degrees, it's going to use this bottom row no matter what. So you're going to have pump speed. Okay, and then for the top here, at 220, let's say we want max flow rate. Let's just say we put down 5. So 5 is going to be 95%. Okay, 86 to 97% is going to be maximum pump speed. Voila, easy. Going to interpolate those, and so on and so forth. So I'm just going to paste what I put down earlier because this is what I've been using and it works well. So our proactive way of getting heat out of the engine is with TPS. So I have a turbo truck. I start getting into boost around like 50 to 60% throttle. Ideally, that's when it really starts making some boost down low. So I'm going to start increasing pump speed a little bit. You could increase pump speed with RPM if you want to, but there's a reason I do it with TPS. This pump flows so much coolant, even at low speed with no thermostat, that it has really no issues keeping the motor cool. It's just whether or not the radiator can keep it cool. I have a very inefficient radiator set up on my truck because I have a 4-inch intercooler in front of it, and my truck was... The Dodges, for whatever reason, they don't create a lot of negative pressure behind the radiator or a lot of positive pressure in front of the radiator. I don't know what it is, but I could take the fans off that truck and get on the highway, do 55 miles an hour, and I could watch it overheat if I wanted to. As soon as I get up to like 70 miles an hour or so, it starts drawing heat out. So I got so annoyed with my fans kicking on and off, especially during the summer. Sometimes they would just kick on and they would stay on for long drives. I was worried about the motor, getting overheated if I lost a fan. I have no way of pulling heat out of it. So what I ended up doing was I put a set of Volkswagen fans on it, and they're PWM as well. So at the very least, they're soft start. They come on really slow. They don't come up to max speed. 99% of the time, those fans are not above like 10% PWM. And they're really quiet, so those seem to work really well. But anyway, in this case, what I have it doing is, so I have my reactive, which is my coolant temp, and then I have my proactive heat removal, which is with TPS. So the reason why I went with TPS is the ability for me to cool down the vehicle in the pits, right? I mean, if you did it with RPM, I'll show that in a second. We'll figure it out on the fly, how to control it and make it nice that way. But with TPS, I'm guaranteed to always have the ability to just say, turn the key on, floor it. Don't start the engine, just turn the key on and floor it. Pump speed's going to go to max because it doesn't matter what my coolant temperature is. It's going to be putting out 95% rate. It's going to be putting out the maximum percentage of the pump speed, which then in combination with that, I have my radiator kick on very similarly to this. It's coolant temp versus TPS. So in the pits, I can go from 185 degrees on the return road. When I first pull it into the pits, I think I was like 185 degrees or so, because it went back to its normal programming where it's trying to regulate 184. And I shut off the engine, turn the key on, open the hood, and just floor it. And then the fan goes to max speed, the pump goes to max speed, and I dropped the temperature right out of the truck. It went from 185 to 120 in about a minute to a minute and 20 seconds. And I still had plenty of battery to spare. I just keyed it off and waited a little while and it cranked right up. So you have the ability to really cool this thing down very fast. So I like to have the control of that. Now, if you were to do it with RPM, you can do it kind of similar, and you can say put like 0 RPM. So if engine speed is 0 and coolant temp is whatever, like say let's do 140. Let's say at the staging lanes you like to be at 140. So we'll go 140, but we're going to still leave this 164 here, okay? Because everywhere else we're going to want it to be, we're going to want it to be doing its normal programming. So at 140 degrees and 0 RPM, we're going to turn the fans off. So to turn the fans off, stop is 0. Oh, okay. Or to turn the pump off, it's going to be 0. Okay. So we're going to put in 100%. But everywhere else, we're going to put 5. So then what this will do, and like let's say we just get to here, let's just go at 4,500. So but 4,500 and over, we'll just make that 100% pump speed. And we'll just interpolate just to make it look cool. We'll fill the rows. Okay. So at 0 RPM, so this would just be the key on, engine not running. It's going to maximize pump speed until it gets down to 140 degrees. Now, if you combine that with like a manual switch on your fans, if you combine that with many things, this will just put the pump on max speed. With the fan on max speed, you could just pull the heat right out of it. So you could do it based on RPM this way as well. You could also put an input trigger on this, so this won't run. In other words, the PWM, which provides the negative signal, doesn't run until, say, 300 RPM. In other words, if your key is on, the pump is on max speed. So you don't even, that way you can take the floor right out of it. But I like to put some sort of a cutoff just in case you'll leave the key on accidentally and walk away. The pump will eventually turn off. It's just going to wait until coolant temp gets to 100 or down to 140. So this is a good way to just key the truck on or key the car on, walk away, go have a soda and hang out with your buddy while the truck cools down. When it's done cooling down, you'll know because you'll hear the fans turn off and you'll hear the water pump turn off. But let me tell you this, the water pump is very quiet, so you're probably not going to hear the water pump turn off. So that's another way you can do it. I mean, you know, sky's the limit as long as you monitor this stuff and just make it the complete opposite. It's pretty easy to figure out. You're just going to have to take 100 and subtract these numbers to get your actual speeds that you want to run. So in reality, it's going to be, say, 87% to 5%. We just established that. I just showed you here. 87 or 85 is what I used. My bad. I think in the beginning I would use 87, but 85% to 5%, that's like minimum pump speed to maximum pump speed. And that's my reactive, and RPM is my proactive heat removal. So I could go on and on about how to set up stuff in the Holley. I love doing it. It's a lot of fun. But I'm going to let you guys go. Let you dwell on it, stew on it, leave comments, let me know what you feel about it. Let me know if it helped you, or maybe you're thinking of going to this pump now that I've made it easy and showed you how to do it. I can tell you this right now, it's a great pump. I have had no problems with it. I would like to see more people run it, especially guys that are running like remote radiators, like a lot of like S10s or trucks where they put like twin turbos up in the front. They want as much pump speed as they can get to send water to the radiator in the back, but you have more head loss because you have more tubing that you have to push through, right? So all that tubing has friction. The world's not perfect, so that's going to decrease your flow rate. Well, something like this, you could get a substantial amount of flow rate, and because it's remote, you could even mount the pump in the bed. I mean, you can get one more thing out of the engine bay. And for reference, this pump is incredibly small. It is incredibly thin with no pulley hanging off the front of it. And it's very light. So there's no need to go out and spend buku dollar on a remote water pump block kit. I know they're I mean, they're pretty expensive, in my opinion. You can do something like this. It's not a part that's going to fail. There's no moving pieces. I don't think I've ever heard of an LS water pump cracking unless, actually, no, I've never heard of one cracking. So you get them in just about every junkyard motor you pick up. You're going to get a pump. You can shave the pump, paint it, make it look nice, do whatever you want. You could even leave the pulley on it. You just have to gut the impeller out of it. And then you have a nice idler pulley. And you can save yourself a lot of money. I mean, all in, you're spending under $100 on this pump setup, and it's going to outperform the stock pump, the Meizere pump, the Davy Craig 150. I mean, there is no other pump on the market that can compete. And if you don't want to take my word for it, you can look at what Rob Dahm is doing with his 1,000 horsepower RX-7. I didn't even know he was running one of those until someone on Sloppy mentioned it to me that, oh, that looks like the pump that he was using. And he sent me some links to the videos and the timestamps. I was like, yeah, that's exactly what it is. He's using, like, say for instance, oh, all this is too much wiring. This is awful. What will I ever do? This company, Tecomotive, sells a controller. They sell a controller. It does the same thing I'm doing, but it sells a controller, and it will control this thing no problem. I think it will even control the fan. Maybe I'd have to take a look. I don't know. Take a look into it if you're interested. It's pretty expensive. I think it was like, yeah, I was gonna say it was like 170 or something like that last time I looked. But you got a little bit of dash bling there. Everything plugs in. It's easy, and it still costs less than a Meizere. So I mean, if you want something that you just plug in and go, I mean, I don't know. It's even got integrated cooling fan controller. Like, yeah, it's got the little fan controller. So I mean, it's pretty nifty. Like, you could save 2 outputs on the Holley by getting this. In my case, I don't have like a whole lot of outputs. I usually need more inputs than I do outputs, so I don't mind using the outputs up. But I mean, you got like a few $100 to spend, and you're fine with what you just paid for that for the CWA400, used or new. I mean, both are pretty good costs, to be quite honest. You can get one of these things and add some more bling to your whip. I mean, you can use an Arduino. You could pulse it with an Arduino. You could replicate this with like an Arduino Nano or something if you're into programming. You can make it work that way. Just, you need some sort of a coolant temp sensor. And yeah, I mean, it's pretty cool. So I hope you guys enjoyed. Sorry, went back onto like a little mini rant there. But I wanted to make sure that this got covered because I totally forgot to mention that. And give, Tecomotive some love. I'm not the person who came up with the original idea. This is them. This is them who came up with it and provided all the info for us. So, and then of course, Ballinger Motorsports. If you want a new connector, they're the only place that I can find that has a new connector. So you kind of have to pay the price and just deal with it. Unless you're pulling it from a junkyard and you can just clip, get yourself a free pigtail with it. All right, guys. Well, that's it for tonight. I hope you guys have a good one. Happy New Year, and see you more in 2020.